In this video, we're going to talk about improper integrals. Improper integral is when you have lower or upper limit, or both of them are, that involves infinity. So for example, look at the first example. We have a to infinity, integral of a to infinity. The upper limit is infinity. And the second case is when the lower limit is negative infinity to b. And the third case is when you go from negative infinity to infinity. So in this video, we'll talk about how to evaluate improper integrals. So let's find the integral of 1 over x dx from 1 to infinity. So in order to evaluate this, we need to put a limit as b goes to infinity of integral from 1 to b. Notice we just replaced infinity with b because we are letting b goes to infinity. I'm going to rewrite 1 over x as x to the... Actually, let's just leave it as 1 over x. And dx. Now that's going to be limit as b goes to infinity, and the integral of 1 over x dx is natural log of x from 1 to b, and it's going to be limit as b goes to infinity of natural log of b minus natural log of 1. So what happens as b goes to infinity? What is natural log of infinity? It's going to infinity. What is natural log of 1? That's 0. So it goes to infinity, which means that you do not have this answer is not finite. So we say it diverges. This integral diverges because we do not have a finite answer. If we have a finite answer, we say it converges. Let's evaluate the integral of e to the x dx from negative infinity to 0. So we need to rewrite this limit. Now as a goes to negative infinity, integral of a to 0, e to the x dx. That should equal to limit as a goes to negative infinity. What is the integral of e to the x dx? It's just e to the x. And then 0, a to 0. So you get limit as a goes to negative infinity, e to the 0 minus e to the a. Now what is e to the 0? E to the 0 is 1. Now what happens to e to the x as a goes to negative infinity? Let's take a look at graph of e to the x. As e to the x approaches negative infinity, as it goes to negative infinity, what's the y value that it's approaching? It's going to 0, isn't it? So it's going to be minus 0, which is 1. So in this case, we have a finite answer. So we say that this integral converges. Also, let's look at it graphically. What does this mean? You're finding the area underneath the curve of e to the x from negative infinity to 0. So basically, you're finding the area of this right here. When you do that, the area underneath the curve is actually 1. But if diverges, that means you cannot find the area underneath the curve. Now we have integral of sine x dx from pi over 2 to infinity. So we want to write it as limit as now b goes to infinity of integral from pi over 2 to b of sine x dx. So antiderivative of sine x is negative cosine x from pi over 2 to b. And this is the same thing as limit as b goes to infinity of negative cosine of b plus cosine of pi over 2. And you know that cosine of pi over 2 is 0. So you end up getting a limit as b goes to infinity of negative cosine of b. So what happens to cosine as b goes to infinity? Well, as b goes to infinity, cosine fluctuates from negative 1 to 1. So you don't get to a finite positive. It just fluctuates between negative 1 and 1. So therefore this diverges. So we could say that this integral diverges. Now let's take the integral of e to the x dx from negative infinity to infinity. So this improper integral has negative infinity to infinity. So what we need to do is we need to choose a nice number, like a real number, so that we could break this part into 2. How about 0? First, let's check if e to the 0 exists. E to the 0 is 1, so we're good. So I'm gonna break it into negative infinity to 0, e to the x dx, plus integral of 0 to infinity, e to the x dx. Now instead of 0, you could also choose 1. But 0 is always a nice number to work with, so I chose 0. Now we have to rewrite this as limit as a goes to negative infinity of integral from a to 0 of e to the x dx plus limit as b goes to infinity of integral from 0 to b e to the x dx. So what do you get over here? You end up getting limit a goes to negative infinity e to the x, integral of e to the x, e to the x, and then a to 0 plus limit b goes to infinity e to the x from 0 to b. So what do you get over here? You end up getting limit as a goes to negative infinity, you get e to the 0 minus e to the a plus limit as b goes to infinity of e to the b minus e to the 0. So what happens over here? You get 1, e to the 0 is 1, 1 minus e to the negative infinity. What happens as e goes to negative infinity? E goes to 0. So you end up getting 1 minus 0. What about over here? It goes to, as b goes to infinity, that goes to e to the infinity. And what about e to the 0? That's 1. So you end up getting e to the infinity, which is infinity. Therefore, this integral, this improper integral diverges because we do not have a finite answer.